Hey guys, it's Miss Peltier again, and we're here for our 8th installment for our distance learning Algebra 2 from Alvin High School for our coronavirus extended leave from school. This is now our 8th one, so I'm not going to go through all the stuff. Hopefully you've been visiting all of our websites. Hopefully you've been taking advantage of our Google Hangouts if you need them. This should be an assignment for April the 8th, and you will have an assignment that will be a worksheet as opposed to IXL. The IXL doesn't do the types of problems that we wanted to see, and your assignment will be due on the 10th. That should be a Friday. So make sure you're staying on top of all your stuff. There's lots of work on these problems, so I want to make sure we get it all in the short amount of time I have. So make sure if you have questions that you reach out to us and jump on our Google Hangouts. Okay? Notice that our steps are exactly the same as the last couple of days that we've been doing rational equations. The difference is with our equation, notice that we have a binomial here on the bottom. When you have a binomial like this, you may want to go ahead and wrap that in parentheses so you remember that that's a quantity. You're not going to look for 2 to be part of your common denominator. You'll be looking for y minus 2. Remember, when you have a whole number, if you need to put it over 1 to remind yourself that 1 is the constant that you're looking at, that's perfectly fine. Now we're going to find our LCD doing the same type of thing that we did before. Looking at our constants 1 and 6, we would need a 6. And because we have this whole quantity y minus 2, we need that whole quantity y minus 2. That will become what I multiply everything by. Y times y minus 2. Y times y minus 2. Sorry, 6 times y minus 2. And 6 times y minus 2. And then we reduce just like we did before. I have a quantity of y minus 2. It reduces with this quantity of y minus 2. And that leaves me with my 6 times 5, or 30. Remember, if you want to skip that step and go straight to 30, you certainly can. On the next one, notice my 1 doesn't need to reduce with anything, but I can go ahead and multiply my 6 and 2 to give me 12, and then that now needs to be multiplied to my y minus 2. This is the main reason why I like to do this step, so that we don't forget to distribute and get that 12y minus 24. And our last one, our 6's cancel, leaving us with 17 times y minus 2. Again, we're going to be distributing. So that gives me 17y minus 34. When we solve, collect our like terms on the left. So I have 12y and a 30 minus 24 gives me a positive 6 equals 17y minus 34. I will move my 12 to the right because I like my y values to stay positive. So when I subtract 12, that gives me 5y over here. When I add my 34, that gives me 40. And now when I divide by 5, I get y to be equal to 8. Now if you recall, in our last one, we did our checks for our denominator to be equal to 0. This, when you have your binomial like this, that's when it's really, really important that you plug in and check. If I plugged into y minus 2 and 8 minus 2, I get 6, not 0, which means it is a good answer. If I got 0, I would throw that out as being an extraneous root. Okay? So, next problem, very similar, but notice we've got a whole lot more stuff down here. So we're going to want to factor each of these first. Anytime you've got a lot of stuff and you can see you've got some factors in there, go ahead and factor those. I like to do it really neatly right here underneath it. I can take out a common 3 and have an n plus 1 and just draw a line through this so that I know that that factor's not there anymore, okay? Or that those numbers. It allows my eyes to focus on this one. If you've been in my class, you know that when I have a minus, I don't like minuses, so I go ahead and make that a plus, a -5, so that I don't lose that negative. I prefer to use a plus for a symbol and then just use my negative sign. I tend to not lose them as easily if I do that. Again, I can factor out a common 4, and I'm left with n minus 1. And same on the last one. I can factor out a common 2, and I'm left with n plus 1. So again, looking for our LCDs, looking at our constants, we have a 3, a 4, and a 2. Since 2 divides into 4, I don't need to worry about the 2. Just focus on the 4 and the 3. So 4 and 3 gives me 12 for an LCD. Don't forget, with your binomials, I have an n plus 1, so I need one of those. And I only need one because remember, there's only one per fraction. If it was n plus 1 and another n plus 1 with this same fraction, I would need 2 of them. But I don't. I only need 1 for both of these. And then I need an n minus 1 for the one in the middle. So that everything that I've got is included in part of this. So now I'm going to multiply by my 12 times n plus 1 times n minus 1. So now do you see why we left so much space? So I have a 12 times n plus 1 times n minus 1. Notice I kind of slant it a little bit, but so that it doesn't interfere with this and I can still see all my numbers nicely. Just write it neatly so that you can see what all's there. N plus 1, n minus 1. Okay? We will still reduce the same way as we reduced before. Notice my n plus 1 and my n plus 1 cancel. My 3 reduces with my 12 to give me 4. So on the top, I really have a 4 times 7n times my n plus 1, n minus 1. I don't want to write all of that, so I'm going to go ahead and multiply my 4 and my 7 and get 28n. And then I'll have n minus 1. Plus, now when I reduce, my n minus 1 cancels with my n minus 1. 4 goes into 12 3 times. So what I really have is negative 15 times n plus 1. And on my last part, my n plus 1's cancel. My 2 goes into my 12 6 times. 6 times 3n gives me 18n times my n minus 1. Do all our distributing. We have 28n squared minus 28n, negative 15 times n, and a negative 15. When we distribute our 18, we have 18n squared and a negative 18n. Okay, so collect our like terms. On the left, I can put my negative 28 and my negative 15 together so that I have 28n squared minus 43n minus 15 equals 18n squared minus 18n. I can move my 18n squared over. Subtracting it gives me 10n squared. I can move my negative 18n over by adding it, and that gives me a negative 25n, and then my minus 15 equals 0. So just like we've been doing earlier in the weeks, we notice we have a common factor. We can take out a factor of 5, and we're left with 2n squared minus 5n minus 3 equals 0. Don't lose your 5 just yet. Factors of 2n squared are 2n, and n. My factors of 3 will be 3 and 1. So I want my 3 to be over here and my 1 to be over here, because remember when we did our double chin, this will give me 6 and this will give me 1. And I want a negative 5, and I need my signs to be different. So my 6 needs to be negative and my 1 needs to be positive. So this will be plus and this will be minus. And if you did that double chin neatly, you can, or in pencil, you could then erase that and it doesn't interfere with our work at all. We can keep going. So remember now, we have our factors. We're going to take each factor, 2n plus 1, set it equal to 0. N minus 3, set it equal to 0. Move my 1 over. 2n equals negative 1, so n is negative 1/2. When I move my 3 over, I get n is equal to 3. I need to double check those. If I have a 3 and I plug it back in, now what I like that works nicely is you can plug it into where you factored. So 3 plus 1 gives me 4. It's not 0. I'm good. Negative 1/2 plus 1 is 1. It's fine. 3 minus 1 is 2, so it's good. And negative 1/2 minus 1 is negative 3/2, so they're both good. So those two answers would be both good answers. Okay? Now, hopefully we get through all of these so that we have enough time, so I'm going to go a little bit faster. Notice my factors. I have a plus, so I'm going to make that a minus. I'm going to make that plus a negative. I'm going to factor this. When I factor that, this factors to be z plus 1 and z minus 1 from our perfect squares that we did earlier in the week. So notice that my LCD will be the quantity of z plus 1 times z minus 1. And you want to multiply it as factors. Don't think, oh, well, that's just this. I can just use that. Because when you go to multiply it, then you don't have anything to reduce with. So you want to multiply it with as the factors. So z plus 1, z minus 1. And z plus 1, z minus 1. And z plus 1, z minus 1. Notice my z plus 1's cancel. When I distribute, that gives me 2 times z minus 1, or 2z minus 2. Plus my z minus 1's cancel. That gives me a negative 1 times z plus 1, which is a negative z minus 1. And my z plus 1's and my z minus 1's cancel, leaving me with a negative 2. When I collect my like terms, 2z minus z gives me just 1z. Negative 2 and negative 1 gives me a negative 3. When I move my negative 3 over, I get z is equal to 1. But notice when I take that 1 and I do my check and I plug 1 in, and I have z minus 1, when I plug 1 in and do 1 minus 1, I get 0. That tells me, this is not a good solution. And since that was our only solution, we're going to say that there is no solution. So that is why we have to check. You don't care if it works in the other one. If it doesn't work in one, then you're done. Okay? So the only, I probably won't get through answering questions on or working through the next one. Notice the only difference, it's a lot of the same stuff, but when you factor, you're going to need to factor this. P and P, you'll have a 4 and 2. You'll have a plus 4 and a minus 2. So you'll use that as your LCD, okay? So I'll leave that for y'all to work. I will finish working it to post, but I will run out of time for recording. So I'll finish working it, so if you want to see the work, you can look at the printed version of it. Check my Google Classroom. It'll have all of your pages, the video, the blank, the filled in, as well as your assignment. This is a worksheet assignment, and you'll load it up into your Google Classroom for me, okay? If you have any questions, remember our Hangouts. Mr. Cleland's at 9. I'm at 11. Miss Blatt's at 1. Mr. Monbruin is at 2. And I'll be back at 7. So if you need anything, let us know. In the meantime, social distancing, wash your hands, be safe. See y'all later.